What if I told you two identical-looking powders could be totally different because of hidden impurities? What makes a substance pure? Let's find out, because this can change everything from medicine to your morning tea. In GCSE chemistry, a pure substance means a single element or a single compound, no mixture. If there's anything else mixed in, that's impure. When you think purity, think precision, a sharp melting point, a defined boiling point. Impurities mess that up. They blur it, depress it, raise it, distort it. So why is purity super important? In making medicines, you need exact doses. In food, safety. In chemicals, consistency. One impurity might make something unsafe. Here's how chemists spot impurity: by checking melting or boiling points. A pure sample has a sharp melting point, say exactly 170 degrees Celsius. Impure sample might melt over a range, say 160 to 170 degrees Celsius, or melt at a lower temperature. Same with boiling. Think of a boiling point curve. So how do we go from impure to pure? GCSE Chemistry Single and Combined Science covers several methods. We'll run through each with examples so you can picture them clearly. First up, filtration. Imagine you've got a beaker full of muddy water. You want to separate the solid bits from the liquid. What do? You grab a filter funnel and some filter paper. Pour the mixture through the funnel and boom! The solid particles, called the residue, get trapped in the paper. The liquid, called the filtrate, drips through into the beaker below. It's like a chemistry version of a coffee filter. Now, let's talk about crystallization. Say you've got a solution, like salty water, and you want to get the salt back. Here's how. First, heat the solution gently to evaporate some of the water. As the water evaporates, the solution becomes more concentrated. Eventually, the salt starts to form crystals. Let it cool, and you'll see beautiful crystals forming at the bottom. This method is great for separating a soluble solid from a solution. Simple distillation. This method is used to separate a liquid from a solution. Here's how it works. You heat the solution in a distillation flask. The liquid with the lowest boiling point evaporates first. The vapor travels through a condenser where it cools and turns back into liquid. The purified liquid is collected in a separate container. Example: separating pure water from salty water. Exam tip: the salt stays behind because it doesn't evaporate. Fractional distillation. This technique separates two or more liquids that have different boiling points. Here's the process. Heat the mixture in a flask. The liquid with the lowest boiling point evaporates first. The vapor passes through a fractionating column, which helps separate the liquids more precisely. Each liquid is collected as it condenses at its own temperature. Example: separating ethanol from water. Real life. It's used in oil refineries to separate crude oil into petrol, diesel, and other fuels. Chromatography, a clever technique used to separate mixtures of coloured substances based on how they travel through or across a medium. This tells you which components are in your mixture, for example, which dyes in a pen, or impurities in a food colouring, and drugs. Let's walk through the practical step by step. Start with a strip of chromatography paper. Using a pencil, not a pen, draw a straight line about 2 centimeters from the bottom. This is your baseline. Now, place small spots of ink or dye on the line. Make sure they're spaced out and not too big. Pour a small amount of solvent, like water or ethanol, into a beaker. You only need enough to cover the bottom. Carefully place the paper into the beaker so the bottom edge touches the solvent, but the ink spots stay above it. Why? so the ink doesn't dissolve straight into the liquid. As the solvent travels up the paper, it carries the dyes with it. Different dyes move at different speeds, depending on their solubility and how strongly they stick to the paper. This causes the dyes to separate into colourful spots. When the solvent gets near the top, take the paper out and mark the solvent front. That's how far the liquid travelled. You've now got a chromatogram, a pattern showing the separated dyes.
But how do we compare these results scientifically?
That's where the RF value comes in. It helps us identify substances by how far they travel. The RF value is calculated using this equation. RF equals the distance travelled by the substance divided by the distance travelled by the solvent front. For example, if the spot travels 2.5 centimetres and the solvent front moves 5 centimetres, then RF equals 2.5 divided by 5, which gives an RF value of 0.5. Remember these important tips for your GCSE exam. Always use pencil for the baseline. It won't run in the solvent. Don't let the ink spots touch the solvent directly. RF values are always less than 1. Measure distances from the baseline to the centre of each spot. A separating funnel is a glass container shaped like a teardrop with a tap at the bottom. It's used to separate immiscible liquids. That means liquids that don't mix, like oil and water. They form layers instead of blending together. Start by pouring your mixture of immiscible liquids into the separating funnel. You'll quickly see 2 layers form. Usually the denser liquid sinks to the bottom and the lighter one floats on top. Wait a few moments to let the layers fully separate. This is important. Rushing can mix them back together. Place a beaker underneath the funnel. Carefully open the tap to let the bottom layer flow out first. Close the tap just before the top layer starts to come out. Now place a second beaker and open the tap again to collect the top layer. Boom! You've successfully separated 2 liquids. If this video helped, hit like, share it with a friend, and subscribe for more GCSE science hacks.